Hey guys, in this video I want to share the Taig CNC machine that I have. It's actually for sale and I built this enclosure for it, and I kind of wanted to explain what I did, how I built this, what kind of features it has, because there's a lot going on here that's not with the original system, and I kind of just want to demonstrate that so people can either do this themselves, or if you're interested in buying my machine with the enclosure and everything that comes with it, including this computer, then keep on watching. So to start off, the machine is a Taig 5019 DSLS. This has the anti-backlash ball screw option, and it has the variable speed spindle. And this actually isn't even on Taig's website. You have to custom order this. It lets you change the spindle speed based on the G code that you receive instead of the belt pulleys like the original manual model would have. We also have XYZ home switches. These are limit switches. And this is kind of, instead of using the software defined limit switches, you can there's manual switches here, so you can have both like a physical trigger for the switches and a software one. There's also the USB module, lets you communicate with the computer, kind of an essential item, and the Mach 3 software license that this machine uses to run, as well as their standard tooling package to kind of get you started. So all of that is included. And I'll get into that a little bit more. I'll lay out all the tools and stuff for you to see. But right now I just want to tell you exactly why I made this. So first off, I had a problem with chips getting all over the place, and I wanted to use a cooling system. So at the very beginning, I started with a mist cooling system, and that worked great, but it was still pretty messy, even though it wasn't like a flood cooling system where fluid would flow everywhere and you have to catch it. This mist system would still get pretty messy, and water would get everywhere. So I needed a way to contain that, but I also wanted to contain the chips more, make it easier to collect that, make it easier to clean the machine. Also, I wanted to reduce the noise. So this enclosure, by the way, is fully insulated with Rockwool. So there's all the walls are padded with Rockwool inside of it, all around, except, you know, obviously the window. So that's kind of the start of it. And because I built this enclosure, I thought, you know, I could step up to flood cooling. And that's what I did, and that's what you can see there in the back. You can see the pipe coming up, and then you can see the nozzles spraying and clearing the chips for you. And I'll show you underneath where I store the pump and how that works. And you see the drain and the filter right there. Another thing we have is a light. That's why you can see the machine so well in here. There's a light up there that can help you kind of see what you're doing, see the machine better from a distance, and it's super handy. We also have 2 fans. You'll see that's what this pipe here is. This ABS pipe is here too. That's where the air flows, and it gets sucked up in the back corner there. Not sure if you can see it, but there it is. That's where it sucks. These are just quiet bathroom fans. It removes, and you can see where it expels it from there. So you can attach it to like a dryer port if you want to kind of if you're running the machine for a long time and you don't want to fog up the room or the garage, you can set up a dryer port outside and it will just expel it out there. So the reason I set this up this way is to kind of cool the motor better, clear up the humidity inside the machine, especially because the thing is I was running this machine for a long time. Whenever I'd have like pretty long cycles, so I just wanted to make sure the life of the machine was maintained, and I added that. Another major thing I want to show you that I did is I changed this from a belt drive motor to a chain drive motor. And let's see if you can see it. Yeah, so back there you can see the chains, and there's like the gearing is maintained. This is the same gearing pretty much as the Taig like stock, so that wasn't changed too much, but the ratio changed a little bit, and there's a way that I tweaked it so it shows you the right value, and I'll show you that on Mach 3 when we get there. The way that they set up the gear reduction and the drive for this motor, it had a tendency of burning up the belts, and what was happening is the belts would kind of skip a little bit, and it would like cause a lot of friction, and it'd basically burn up the belt. So I was getting tired of replacing the belt all the time. It caused some downtime, and I installed the chain drive, and it doesn't have that same issue. And you can actually get a little bit more power out of it. The motor itself, you know, has the same power output, but the problem was that the belts couldn't handle the power that the motor was putting out because the belts were really tiny, and it would start slipping and burning up and starting to warp. So that's what's going on there. And because I installed the chain drive, it would have more heat because it kind of needs to be lubricated. And that's why I set up a cooling hose behind it. That's why there's this cooling manifold here. I have one set up to kind of shovel the chips, one to hit the tip of the cutting tool, and one in the back to spray the chain. And you can see that I kind of turn the knob a little bit, so it's just kind of like a trickle, just to kind of keep the, you know, I'm not spraying the chain drive. I'm just kind of keeping it moist, keeping it cool. Yeah. So moving on, we can go over this construction here. This is basically just conduit that takes all of these control wires and sends it down below to the bottom cabinet. There's a rubber, you know, like a rubber gasket, nothing really flows down, and there's this drop here so nothing can kind of come up inside, and all the electronics stay safe that way. Never had an issue with that. What else? We have, this is a steel base, so this machine is very, very stable. It's not going to move, it's not going to vibrate here. This is all screwed down very well, and the Taig is bolted down to this metal plate. And this is like a U-channel. This is like an architectural steel, so this is very stable. And you can't really see it here because I kind of hit it, but the steel goes all the way out to here. So there's a big flange that it sits on. So this is the basin. It collects all the chips, collects all of the fluid, and sends it back down this gutter, and that goes back into the pump for the cooling system and shoots right back up the pipe. Couple things I want to mention here is I use this metal caulking around the edges, and as you're cleaning up this basin from time to time, sometimes the caulking kind of comes up. So you might have to touch up on it every once in a while. That's why it's, you know, it doesn't look super clean right now because I had to touch it up. Yeah, and this window actually is very big. So you can put something really long in there if you need to. If you're working with any kind of like long bars or anything, you can place it in there. Plenty of space to move around the machine, behind the machine, and there's some magnetic latches here to shut the door. And it's pretty quiet, and that's kind of, you know, the intention here. It's a, you know, double walled. This is a aluminum frame. I kind of made this myself. I brazed it, and then I stuck this window on, this polycarbonate window with epoxy. And then I did have to touch up the edges with caulk. Just another thing, you know, you might have to touch things up with caulk. And here's a little breather vent, so it doesn't get fogged up in there. And then this is just like a door seal to kind of keep the fluids out. All right, so I think that's about it for this part. Let's take a look at the switches that I have here. We have, actually first let's move around the machine and I'll show you how this even gets power. So on the side here, we have an appliance outlet. All I have to do is plug in an extension cord and then the machine gets powered up. This panel here is an access port. You can basically see all the electrical wires running down across and up to the fans. So that's kind of like a service port. If you want to change anything, feel free. Let's take a look at the front. The front has a computer that's bolted onto this ram mount. This is basically what emergency vehicles use to mount their computers. And you can swivel it. So this is actually really cool because whenever you're out here and let's say you're trying to find, you know, your zero position and you're trying to jog, you know, the machine, you can just swivel this over like this and just use your hands while you're looking over here, and you don't have to pivot too much because you can move the computer really close to you. And then whenever you're ready, you just kind of swivel it back. You can shut the door and all's good. So yeah, let's go over these switches. We have a switch basically for everything that's attached to the machine. So let's show you what that means. So we have one switch for the PC. That's basically just the power brick. So that turns on that outlet back there. And then you have two more outlets, and that's what these two switches are for. The XYZ, this is for the stepper motors. So that's that controller on the bottom there. Then we have the variable speed spindle controller. Turn that on, and that's the box at the top right there. You're always going to have these two things on at the same time, and the VSS, variable speed spindle controller, that's the one that communicates with Mach 3 with the computer. So if you don't have the VSS on, you're not going to see anything on the computer. So you're always going to have those on, but I kept them separated. I kept this outlet separated on different switches because that's kind of what they have on the back of the machine. You can turn them on individually. So I tried to replicate the exact same functionality, just in a more convenient fashion. Because before, whenever this was just on a table, these would be off to the side, and then there'd be chips, and then you have to reach behind there and turn on those two little toggle switches. It just wasn't very convenient. So I try to, whenever I made this, I try to make everything a lot more convenient. All right, so, and these two things I'll get into at the end. These are just some spare parts and some spare tools. I'm not going to include the box, but this kind of gives you an idea. There's a lot of storage space here. And yeah, so let's move on to the other side real quick. The only thing that's in here is the pump for the cooling system. You can see this chute here, this gutter that drops the coolant from up above down into this reservoir, and you can move this out of the way, you know, like that. And there's a mesh in there as well. So it's easy to take out if you want to service this, replace the fluid, do whatever you need to do. And there's the hose hookup. There's like another hose here, and there's an outlet there. And this one is connected to the flood switch. Now, the way this one works is just by turning this on isn't going to turn on the pump. You're also going to have to get the signal from the G code that says turn on the coolant. So I'll also show that a little bit later whenever I demo the machine. So as you can see, just by turning on the switch, it doesn't turn on the pump. So basically if you're ready to run coolant, you turn this on, and then your program will turn on the coolant if you need coolant, if you programmed it to use coolant. And if, let's say, something's going on with the machine, you don't want to use coolant, just turn this off and you'll know that it will never turn on. Things only run if you want it to run. Before we move on to the demo, I would like to show you this toolbox. It has all the tools that you'll need to run the machine. You got some wrenches to adjust the collet. You got different ER collets there. And you have the chucks, drill chucks. You have some end mills in there, and your collet nut. And this is just, you know, a convenient location to store your tools. And there's a magnetic mat at the bottom. All right, so again, get another look at the machine with the doors open. All right. Next we have the fan. So this turns on those fans that I was telling you about earlier. I turned them on. Okay, now you can kind of hear it. Yeah, there we go. Now that it's at full speed. You can feel blowing here and sucking from there and blowing out from there. And then the last one is for the lights. It's just one light right here. It's an LED light. It's situated up front. That way you can kind of, this shines light onto your workpiece. And I'll show you the filter a little bit closer. This is a handmade filter. All right, so I booted up the computer. Let's take a look at Mach 3. And you might notice that I have a sticker on the front here that says set to 82. It's a reminder. And this is how to adjust the speed of the spindle, so it shows you the actual speed because of the gear ratio change from the belt to the chain. All right, so first thing we do always is hit the reset button, and I'm just going to zero out these for a sec. All right, I'm gonna open the door and I'm going to jog the machine to kind of show you its movements. So that's moving in the X, and it can go faster. This is just kind of the speed that I'm more comfortable with when running the machine while jogging. So that's kind of what I set it to. And then this is the Y. And now the Z. All right. I do want to show this panel too. This is actually what is on the VSS controller, on the face of the controller. So that's also why the controller box had to be really close to the machine, and why I didn't want it getting messed up is because you kind of want to have access to these while you're running the machine. These were originally on the face of that control box, but you can see this set of wires here, and I just kind of extended the wires and moved it here so I can conveniently control it from the enclosure without touching the controller. So I'll go over what these mean. The first part is the switch, and in the middle is off, on the bottom is manual, and if you put it on the top it's auto. So with manual mode you can rotate the spindle using this dial here. So I'll turn the dial and I'll have the camera pointing to the spindle there. There you go, you can see it rotating. And there's a chain drive working. It is a bit louder with the chain drive, but thankfully it's in this enclosure, so that kind of helps cut down on the noise. And this is just like the lowest speed. This is 800 RPM, and you can obviously turn it up. And that went to about 5,000 RPM. All right, so we also have the auto mode, and this basically just, it lets Mach 3 control the spindle. So you can basically type in here what you want the spindle speed to be, and it will go ahead and do that. So we can do that here. First, I'm going to do what my sticker says and set this number to 82. This basically just kind of scales back the number. So let's say I want to run it at 2000. So I can turn on the spindle with this button here. And there you go. So that's not using this dial, and that's whenever this switch is set to auto. And you can see the RPM is about right. It's close enough. And that's what that set to 82 does. It kind of aligns it better. That way when I say 2000, it'll get to 2000-ish. And even stock, it would have that few hundred, almost thousand of error, depending on what speed it is. Some speeds is more accurate than others. All right, so let me load in a program, and that'll give you a demo of how it runs on its own. So here we go. To load G code. And there are plenty of tutorials on Mach 3. I will also provide all the documentation that this machine came with. I kept everything. All right, so I'm going to hit cycle start on this program. All right, so I stopped the program. I think that was long enough. Demonstrated a few drilling operations. That was at 2000 RPM, which, you know, I would consider a pretty safe speed to run the chain drive without the coolant. I don't have coolant in the machine because I'm not using it anymore, and I don't want to fill it up with coolant and then whenever I sell it, having to dump it and clean it again. So I will show the coolant pump working momentarily though, just to kind of give you that peace of mind. So there's a red dot in here that you'll see spinning. So let me back up, turn on the flood switch, go through the whole process with you. And there is a flood button here. Let's actually do the computer one first. All right, so there's a flood button here, Control F. So you can see it's on. And then I'm going to flip the flood switch here that provides power. And you'll see this red dot start spinning. So let me flip the switch. Hold on, let me get this to focus. All right, flipping the switch right now. All right, I think you could hear that as well. And you could see that the orange sticker indicator spinning. So now it's slowed down and it stopped spinning. All right, so I think that's mostly it. Let's actually go through the tools real quick. So let me show you all the spares that this system comes with. So there's a spare pump here. I'm not sure if it still works. I'm not sure what the deal is with it because I replaced the pump. Well, it stopped working once and I replaced this pump. But while I was replacing it, I turned it back on and it started working again. So I don't know if it was some kind of electrical connection in the pump itself in here whenever I got it. But last I checked, this worked, but I still switched it anyway because I didn't want to have to deal with it if it actually was broken. All right, next up is what's in this bin. This includes some of the parts I took off, and it has the vices actually. You'll see the two vices that the Taig comes with. They are definitely used a bit. See, a few mistakes were made at some point. Lost a few of the end mills. Got some parallels, aluminum parallels. Got some T-nuts and some more T-nuts. Basically work holding stuff. Some nuts that actually fit in to the slots, so you can secure your work. I got some spare lock line. This is for the coolant. So if you want to extend the line, use a different tip, add a plug. They're there, it's yours. Some extra chain. You're probably not going to use this, but it gives you an idea of what I used. This is actually the box that the flood controller, well, it wasn't a controller, but I replaced this with this box. So it's technically electrically the exact same thing. They just used this, they had this switch here, and then they had a solid state relay in here, and the controller would send the flood signal that way and turn on the pump. I have the exact same setup in here. It's just built into the enclosure, and the solid state relay is inside of that box. A shield. I don't even remember where this goes, but it's there. You can see the old belts. I tried some different sizes out actually as well, and I think these might still be the good ones. But they're here. This is what they used to look like instead of the chains. These are the pulleys for the belts. I used different cogs for the chain. I did take one of the pulleys and modified them. So there's actually a third pulley, and that's still on the machine. That's how I can still maintain the RPM readings but you cannot go back with those. With that one pulley that's on there, you can't put the belt back on. You're gonna have to get that pulley from Taig, and they're really good about spare parts. That's how I got these belts, and they'll send you whatever you need at a really good price. They're not gonna, they didn't mark up the prices at all for me. They're pretty honest about it. So if you ever wanted to go back to this belt drive, you just need these two pulleys. These are unmodified, and you would need the other pulley with the RPM signal magnet built in. I'll show you. That's the aluminum pulley right here. Yeah, and you can see that magnetic part. That's how it gets that RPM reading. So this pulley right here on the bottom, that's what needs to be replaced if you want to go back to the belt system. The rest are just extra screws. There's an extra connector they gave me. If I ended up getting water on a connector, I didn't have to really do anything with that, because I put these, well, these actually came. These are rubber shields for the Waycovers. They're on there. This one I put on myself, and that kind of protects the motor, because whenever you're running any kind of cooling system, not even this one, like mist, like the most basic stuff, this will get wet. The motor will get wet, the connectors are going to get wet, so that's why this Waycover is here, and it does a pretty good job. And yeah, so that's everything. Let me actually pull out the book, the documentation that comes with, because it kind of gives you a good overview of how to use this machine if you're an absolute beginner. I was an absolute beginner, so this is how I learned how to, write G code, do anything CNC related. It was all on this machine, and I'm very grateful for it. But I've moved on to much bigger systems, and I enjoyed my time with it. But yeah, let's take a look at the documentation real quick. All right, so this is the notebook that it comes with. There's a CD here, includes all the software you need to run, and it actually has my license number for Mach 3 on the back. So if you have a license number, it's a genuine copy. Goes over how to install the programs, how to use the collets, turn off the control module switch. Yeah, so that's actually a very important thing, and also why I like having this here. If you leave it on auto, the spindle controller, and you turn off Mach 3, it can turn on. And that's what this cautionary note is about. And I think that's pretty unsafe, honestly. So what I always do as a habit, anytime I open up this door, I basically turn this off. So whenever I run the machine, I know I'm going to run it, I shut the door and I turn it on auto. And now it's ready to run. Whenever I open up the door, I turn it on off, and I turn it off, and then I don't have to worry about it turning back on, because this is electrically cut off. So no matter what's going on the computer or anywhere else, any kind of bugs or anything like that, it will never turn on. So that's a big safety feature, actually, having it up front like this. So that's something I keep in mind. Same thing with like big industrial machines, they do the same thing. You open the doors, it cuts off the spindle. So as a habit, I cut this off anytime I opened up the door. Obviously for this demo, I left it open. I didn't have any tools in there, so I felt pretty safe, and I ran it at a pretty low speed. So anyway, moving forward, it shows you some very basic stuff, like which keys to use, the jog, how to connect the cables, what does the back of the box look like, how to wire everything up. Luckily for you, most of this is already done, and I will be giving the computer as is to you guys, so it's already installed. But if anything ever happens, you have this to refer to, and this is the exact information that I had whenever I set this up. So yeah, and it also shows you, just how to do some really basic stuff, and how to adjust the machine, how to take care of the machine, stuff like that. I've been pretty good with lubricating everything and adjusting and making sure things are aligned. But I would also recommend learning how to do that and double checking it yourself whenever you get the machine. So yeah, that's it. That's all I have to show. If you have any other questions, feel free to reach out, and hopefully I can answer any questions that you have. This was definitely a passion project. And oh, by the way, this is on casters, so you can easily roll it anywhere you need to. You can see I kind of this was in the corner of the garage, but I kind of pried it out for this video. And yeah, so reach out if you have any questions, if you're interested in buying it. I mean, even if you have a Taig and you have some questions for me, maybe I can help you out. But yeah, that's all for today. Thank you so much. Thanks for watching.